Okay, so we just finished an activity where we talked about these different trends within the periodic table. And so that's what we're going to talk about is trends in the periodic table. Our essential question is, what can periodic trends tell us about how reactive an element is? And your learning target is, I will explain various trends that appear in the periodic table and how they are related to one another. Okay. So the first trend that we're going to look at is the atomic radius. So the atomic radius decreases as you go across the period. So as you go from left to right on the periodic table, the atomic radius decreases, right? So the more protons you add to the atom, the more it's going to pull those electrons towards the center. So it's going to decrease. Okay. And then going down the group, you're adding more shells. And so the energy is going to, the radius is going to increase because you're adding more and more shells. So you're adding more and more material. Okay. For example, ranking the following elements by increasing atomic radius. So let's compare carbon and potassium. Okay. So carbon is right here. And so carbon is, it's pulled closer to the nucleus. It has less of those core electrons. And potassium has more of the shells. So it has 2 more shells than what the carbon does. And so the potassium is bigger than the carbon. Okay. Comparing carbon and oxygen has more more protons than carbon does, and so those protons are pulling on the electrons, which is making it more closely packed together. So in this case, carbon is bigger than aluminum but smaller than potassium. Okay. The next thing we're going to talk about is ionization energy. And so first you need to know what an ion is. So ions are formed when an atom gains or loses electrons. So in a neutral atom, you have the same number of electrons as you have for protons. If we remove one of those electrons, then it becomes an ion. Okay. Same thing is if you add an electron, that would also be an ion. So if you add an electron, that's going to be what's called an anion, right? So we're adding, so and then if you remove electrons, then you get what's called a cation, not a cation, cation. Okay. With the atomic radius, as we add electrons, as we take away electrons, the radius decreases because we now can pull on those electrons harder. So that means that it's going to decrease. The radius of an anion increases because, again, that lower effective nuclear charge. Okay. So with ionization energy, that is where the amount of energy needed to remove a valence electron from an atom, you need that energy in order to get those electrons out, right? Successive ionization energy is where you're trying to pull more than one, right? You're trying to remove more than one of those electrons. And what we find is that as we take away valence electrons, yes, we have a certain amount of energy that's needed. But when we start trying to take away that third electron or that core electron, we need much, much more energy to try and pull that away because those protons are really tugging at the electrons. Okay. So ionization energy increases across the period. So as you go from left to right, The ionization energy increases because you have more of those opposite charges. Okay. As you go down a group from top to bottom, it decreases because you're getting farther and farther away from that nucleus, right? And so remember, as you move away, you have less force. Okay. Electron affinity is where you're adding electrons, or yes, you're adding electrons. And so it increases across the period, just like if you were taking them away, for the same reason. That effective nuclear charge increases. Okay. It decreases down the group because those outer electrons are getting farther away. Okay. So now you should be able to tell the different trends in the periodic table based on things like the radius and electron affinity and that kind of thing.